The thing is that whenever you do some integral, you always have the c, right? I said after you integral, you choose plus c in case that you didn't put any boundary condition there. The reason why we go to plus c because whenever you have the equation, for example, if you have y equal to 3x squared plus 2x plus 1. When you do some differential of this y respect to x, what you get? 6x plus 3. What about this one? When you do the differential, it would end up with 0. So now when you integrate it back, what you get? Integral dy equal to y. Yeah, you would say, okay, 3x squared plus 2x. Where's the other term? Plus c. You got to make it plus c because you don't know what would be that constant. So that's why I said that if you don't put the boundary condition there, you've got to plus c. But whenever you have the boundary condition, you would know this number would be whatever the number followed by the boundary condition that you give. Okay? Now, that is coming to this part of the study today. Because I just want to, tell you why do we need to have the boundary condition and what that means by initial value. In chemical engineering, sometimes if you look at the time constraint, like whatever varies with time. For example, like when you do the reaction in the reactor, for the batch reactor, you know that the conversion of the reactant always varies with time. And the thing that we always know that the first condition that we put into the reactor, right? And since the concentrations vary with time, at the initial we will get time equal to 0, right? So that's why initial condition is very important for us because it's always the thing that we know first. That means whenever you have the differential equation, you got to know what would be the order of that differential equation. That would lead you to how many initial boundary conditions, or that would lead you to the boundary conditions that you should give to your equation in order to know the solution which is fit to the condition that you want. If you have differential equation with the order of n, you would have n boundaries for that. Okay? So this is what I say in there. To find solution of differential equation that satisfy the x at x0 of the n initial boundary condition, because this is the n order, the order of n. So you need n boundary conditions that you can solve for the solution, something like that. Okay. Let's see the example. This one, they are just asking us to show that this answer is the answer of this equation under this boundary. So if it's under this boundary, then you should be able, let me write this one again, because since this is the explicit solution, so the phi is the 1. right? Because it's the explicit solution. This b actually is the y. It's a function of x like this. But this one you would get, you won't have C1 and C2 because it is the answer from this boundary. If this is the right boundary, if this is the right answer for this boundary, when you put this boundary in there, it's supposed to be satisfied to each other. How do we know? You've got to put x equal to 0 into here. If you put x equal to 0, you would get y equal to -1.